Hello everyone, this is me, Assam Helmi. I'm a business developer at OPA Energy, and I will be your moderator in today's webinar titled Introduction to Well Control. I have a short presentation to give to you just 5 minutes before we start our webinar today. Before I start, I would like to confirm that my voice and that my screen are clear to all of you. So please confirm to my voice and the screen on the chat box by typing 1. Okay, thank you. Yeah, good. Thanks. So this presentation is about OPA upcoming services plan. This is our dashboard, which shows that we are on social media for a while. We have now not 15,000 followers on LinkedIn. We are now about 16,000 followers, and we already have 16,000 reasons to complete what we are doing and sharing knowledge with you all. We have attendance from all the globe worldwide. We have an interesting group of instructors that provide you with valuable knowledge in the energy industry. We have diversity of attendees and instructors as well. This is our second wave, which is the quarter courses plan for 2023. We already completed 3 of these courses, which were rate transit analysis, pressure transit analysis, and acid stimulation. These are finished, and we are now in the fourth course of our second wave, which is well-controlled preparation that will be from the 11th to the 16th of March. We have also a break during this course, which is highlighted in light blue, which is 14 March. This is a QR code for you to scan if you'd like to join us in this fourth course, which is a very interesting course, well control preparation course. We also have plenty of recorded courses available in different softwares, PipeSim, TechLog, Sapphire, OPM, and many interesting other softwares like TrackPad. You can see this all in the left corner of my screen. We have about 22 courses in different interesting topics. We also provide a big sale for all these courses. If you are interested in taking more than one course, for sure you will get a good discount. And as the number of courses you enroll in increases, you will get a big discount on your sale. You can also scan this QR code if you are interested in any of our recorded courses. OPA is not only offering live and recorded courses, we also have a very interesting mentorship program, which is one-to-one program. If you would like to have your own instructor and design your learning journey with us on your preferences, so this mentorship program is the best choice for you. The mentor has different rules. He motivates you, empower you, nurture you, and teach you, offer guidance, and respond to your needs. We already provided more than 34 mentorship programs exceeding 600 learning hours and delivered by different instructors and mentors. I don't want to be long. Also, here is a QR code on the right down corner of the screen. If you would like to tell us more about your desired mentorship program. I'd also like to encourage you all to pay a visit to our website, interesting website that shows different recorded courses well-organized courses in different topics as well. Here are a screenshot from the website. Here is more screenshots if you would like to go check for our interesting courses. We also provide internship programs. We already conducted different internship programs for different group of students from Lebanon. You can see interesting memories on my screen now from field trips and office in-person courses as well. You can enjoy all of our offering by becoming an OBA ambassador. You can become an OBA ambassador just by enrolling in one course, and you can enjoy our discounts and the different offerings that we offer to our ambassadors. Uh, just before I hand over to Engineer I'd like to give some rules for this webinar to be a successful webinar. I already muted all of you. Sorry for that, but this is better for you all to get the best knowledge of this webinar. So please keep your camera closed as well. Put your questions in the chat box, and I will read them during the Q&A part of this webinar. Use your full name if you entered this meeting and your name is like iPhone. Please rename yourself to be able to send you your certificate of registration of attendance for this webinar. Just a note: certificates will be sent to all of you within 1 week from today. Thank you for listening, and I'd like now to introduce our instructor, engineer Amr Ibrahim. Just 1 minute, one more minute to start our webinar. Engineer Amr Ibrahim is a senior drilling cloud engineer with more than 10 years of experience in drilling engineering. He has main experience in drilling high temperature, high pressure wells, deviated wells, and horizontal wells as well, drilling with heavy mud weights. He's experienced in drilling at offshore and onshore rigs, experienced in all the drilling problems. He is accredited instructor and assessor for IWCF, Well and Well Control International certificates. Just one more note that Engineer is one of the oldest instructors with us in OBA. He has conducted a drilling clouds session 3 years ago. So you can imagine today is the 61 webinar, and he is the one that has conducted the first webinar with OBA. Thank you, Engineer Amr, for your successful journey with OBA, and thanks for sharing knowledge with us. Engineer Amr, the mic is yours to start the webinar.
Assalamu alaikum, everyone. Thank you, Engineer Assam, for this great introduction. I can't say more. So I welcome everyone in this webinar. Usually in our courses, I let everyone to introduce himself and tell me what is his or her expectation from this course. But you know, this is a webinar, so it will be difficult to let everyone talk, and that's why I will start talking, and inshallah we will have 10 minutes at the end of the webinar to answer your question, which will be written in the chat box, and Engineer Assam inshallah will organize and provide them to me at the end of the webinar. Just for your information, this webinar is just an introduction for the course that will be held soon, which is introduction also to preparation for well control. As Mr. Assam said, I'm certified and accredited instructor and assessor for IWCF and Well. and I delivered many courses: drilling fluid or drilling engineering plus well control. And I noticed more than one person attended with me before. I think Abdul Hafiz, and I don't remember who is the other person. Anyway, inshallah, I will deliver something to you. And you got anything beneficial from this short webinar. So kindly confirm that my screen is obvious to you.
Yes, your screen is clear.
Okay. Okay, so let's start with usually in well-control courses, the first thing to be started is some definitions about kick, blowout, primary control, secondary control, equipment, and all of this stuff. But usually I like to, just a minute, I want this to be floating. Okay, so I think it's better now. Okay, so but usually I'd like to start with the barrier theory of well control, because everyone, I think, remember what happened in 2010 at the Gulf of Mexico, the Deepwater Horizon awful accident. And you know, a lot of people died at this day, and environmental impact, a lot of impact to PV company. So just as a brief for what happened in this day, or before the blowout, what happened is they run 4.5-inch liner, do seaming job, and instead of testing the cement integrity, they neglect to do the cement bond log and displace the well to the prime, and the cement was not good enough to hold the formation pressure. That's why the blowout happened. And after this date, the IWCF curriculum updated and included a very important part, which is the barrier theory. What is meant by barrier theory? That will we will know now about this very important point before talking about anything in the well control itself. Okay. So the well barrier element is defined as a component part of a well designed to prevent the fluid or gases from flowing unintentionally. And this is the concept of well control. We have a fluid inside our formation. We have everyone, I think in our industry, this is the basic. No, we have 3 pressures related to the formation. We have something called the mud window. The mud window is you have 2 pressures that you cannot control. It is characteristics for the formation. And you have one pressure that you are controlling, which is the hydrostatic pressure coming from the fluid, the drilling fluid weight. So you have the bore pressure or formation pressure, which is the pressure of the fluid inside the formation. And you have the fracture pressure, which is the pressure at which the formation starts to crack or frack, and you will lose your fluid. So the mud window stated that your hydrostatic pressure should be higher than the formation pressure and less than the fracture pressure. We are concerned here about the first part, which is the formation, the hydrostatic pressure should be higher than the formation pressure. Why? Because we want to stop the flowing of any fluid or gas from the formation to be unintentionally flow, and we are not ready to get it. You know that the target for our drilling process is to get this fluid, but we should get it at a certain time when we are ready, when we connect this well to the production facility. So this is the definition of well barrier element. Everyone is thinking about the barrier or the well control in only two main definitions, which are the primary well control, which is the drilling fluid, and the secondary well control, which is the mechanical device, which is the BOP. Most of us think of well control like this, but we don't have, we have another barrier, and we have something called the barrier envelope. Okay, the barrier envelope. So for example, you drill a section, say for example the 12-inch section, and you follow it the well control, you have mud weight higher than the formation pressure, and you finish the drilling, run a casing, do cement job. So you have now a new barrier. It is not only the drilling fluid, but you have now a new barrier. What is the new barrier here? It is the casing. It is the cemented casing. But there is a condition here. If the barrier you have is not pressure tested, so you don't have a barrier. And this will be described later here. So the well barrier envelope, what is the well barrier envelope? It is defined as the combination of one or more well barrier elements that together constitute the method of containment of fluid within a well that prevent the uncontrolled flow of fluids. So here we are not counting on only one barrier. We are not counting on the drilling fluid alone. We are not counting on the BOP alone. We have barriers in our system, and by definition we should have at least two just a minute, gents, I'm sorry. Okay, gents. So we have here the barrier envelope, and by definition or by recommendation of well control, we should have at least two pressure tested barriers. So we can see here we have these barriers, and if all these barriers, you can see the line here. Let's use some, okay, not here. So you have seen this line here. This is the lack of procedures. Okay, so someone is deviating from the procedure. Someone is doing unsafe acts. We have a failure in the primary barrier, which is the drilling fluid. We have a failure in the secondary barrier, and we might have some other failures. So if all of this happened at the same time, so you have a kick and might be blowout. So for example, a lack of the procedure, for example, the driller is not activating the BVT alarm. So there is increase in the tanks, and he is not following it, and he is not acting upon this this event. And we might have a gas intrusion, and the mud logger, for example, is not giving the required attention, and we have a low mud weight than required. Okay, so we have here, if we are losing all of these barriers at the same time, so we will have the consequence of well control losing, which is the kick and then the blowout. But in case we have this barrier, we have the same unsafe act, we have the lack of procedure. We lost the primary barrier, but we have the secondary barrier in place, and this will prevent us from getting the accident of a kick or wheel control. So the concept of barrier envelope is not depending only on a single barrier, but it will depend on multi-layer of barriers. Okay. So what are the types of barrier we have? We have mechanical barriers and hydrostatic barriers. Okay. So as I told you, a double barrier protection. So this is it become a general rule everywhere in the world. You know, the oil industry is a worldwide industry. So this rule is applied to every place have any drilling operation worldwide. So a minimum of 2 tested, and you can put like 100 red lines after these tested barriers. It is not only the barriers. Again, remember what happened in the Deepwater Horizon. They already put casing and do seaming job, but they didn't make cement bond lock. They didn't make any of negative testing. So it might be the cement quality was not good enough. It might you have some leak in the liner gap. So this casing and the cement in this case is not considered to be a tested barrier. So we don't have barrier here. And what we are afraid of already happened, and a very catastrophic accident happened, and a lot of people died. And this is the most important, and a lot of resources wasted, environmental impact, and a lot happened with this accident. Okay, so a minimum of 2 tested barriers should be available at all times. A barrier system is normally an envelope of group or individual barrier element. For example, the stuffing box is only part of the lubricator envelope. This is in the slick line operation. The BOB are part of the lubricator Christmas tree envelope, etc. Okay. So what are the types of mechanical barriers? So I told you before we have 2 types of barrier: mechanical barrier and hydrostatic barrier. And you can easily imagine that the hydrostatic barrier are the fluids. Okay, either the drilling fluid or the completion fluid. So the mechanical barriers are the BOB, okay, the shear seal BOB's valves, the anaerobe preventer, this is part of the BOB, the Christmas tree gate, the sub-service safety valve, okay. Additional downhole barrier, the wire line plugs, but again, if it is not pressure tested, it will not be considered as barrier. Okay, the bridge plug is also considered as barrier. The cement plugs, but again, it should be tested, positive test and negative test, to avoid or to make sure that there is no any leak for these cement plugs. Okay. The hydrostatic barrier, it is very obvious that it is the liquids, but only if they provide hydrostatic pressure greater than the formation pressure. So this is mainly the drilling fluid or the completion fluid, the drilling fluid and completion fluid, or sometimes seawater when we have complete loss and we are counting on the seawater plus some service pressure from the service, in case we have a tool like MBD or something like this. Okay, so mainly the hydrostatic barrier are the drilling fluid or compression fluid. The hydrostatic barrier criteria must provide an overbalance at the top of the formation, must be observable at the surface. You remember every time we got a losses, one of the procedures or one of the recommendations that should be applied is to fill the well with any available fluid you have. For example, if you are in the land rig, so you will fill with water in case you can, or seawater, to see the level of the water and provide for you any hydrostatic overbalance. Okay. If possible, use the plug to segregate kill fluid from the formation. Okay. So this quickly is the barrier theory, and it is very important to be understood before talking about anything related to the drilling fluid, what the problem of well control. So I will stop the share and share the second presentation we have for today. Okay, so my screen is obvious to you?
Yes, it is.
Okay. So let's talk about the main definitions we have in. Let's talk about the main definition we have here in our drilling in well control. Okay, I will excuse you just 1 minute, and please, if you have any question, write it in the chat box, and I will come back to you. Just 1 minute. Okay, gents, I'm back. So let's start with our definitions for the well control. So first one and most basic one is, what is the kick? The kick is an influx of formation fluid into the well, but unintentionally. So we are not putting this fluid, this well into production. So we are drilling the well or completing, doing any completion job in the well, and we have a fluid influx from the formation come into the well. Okay. So if we have a kick, okay, this is happen every day in the world in the drilling operation. So if you have a kick, it is not for sure a consequence, the consequence for the kick to have a blowout. In case you fail to control this kick from the well, so you will have the blowout, which is the uncontrolled exit of the formation fluid at the surface. Like the most recent accident is the Deepwater Horizon, and we all see what happened there. Okay, so this is uncontrolled exit of the formation fluid at the surface. So the formation fluid come to the surface and causing the blowout. So not every kick is a blowout, but for sure every blowout is a consequence of uncontrolled kick. So as I told you before, we have the mud window. We have two pressures that we cannot control. It is characteristics of the formation. One of them is the formation pressure. So we have here the formation pressure. What is the definition of formation pressure? So all the formation we drilled consist of rock grains and pore spaces. As you can see here, this is the rock grains and pore spaces, and these pore spaces have some fluid. Okay, it might be water, it might be gas, it might be oil, and as most of you know, most of this reservoir we are drilling is developed in marine environment, and there is something called the interstitial water around the grain, and the pore spaces, it might have gas or oil or water depending on the type of this reservoir. And this fluid, due to the overburden pressure, have some pressure inside it, and this is called the formation pressure. As a normal case, when you don't have any sorry. As a normal case, when you don't have any activity, so this pressure is normal, no problem, and even if it is connected to the service or not connected, so the pressure downside is not a problem. But when you start to do drilling operation, you have to keep this pressure in control while drilling. That's why we are talking about the mud window. In case you lose this, this pressure, this window is okay. In case you lose this pressure, this control on this pressure, so you will have a kick. Okay. Okay. So what is the well control? The well control is to preventing a kick. Okay. We have the primary well control, which is the mud hydrostatic, or we have, in case we have a kick already, so we shut the well using the secondary well control. And I think every one of you know that we close the well and we do our calculations and we pump the drilling fluid, which is a kill fluid. So we restore the primary control. Okay, so even if we have a kick, if we lost this primary control and we have to use the secondary well control using the BOBs, so it's okay. We will close the well, secure the well, reading the pressure, shutting drill pipe pressure, casing pressure, all of this stuff. And the main reason for this is to restore the primary pressure, the primary well control, by pumping the kill fluid. Okay, because this is the primary well control is the main barrier while drilling or doing completion job. Okay. Okay, so the primary prevention. So we are doing the primary prevention here. Don't forget that we are counting on barrier envelope. Okay, we are counting on barrier envelope. So we are doing, for example, if we are drilling, so we are using hydrostatic barrier, which is a drilling fluid, plus the BOB, which is another barrier. If we lose this primary barrier and we are monitoring the well properly, the mud logger is monitoring the gas level, the driller is activating the PVT alarm, the derrick man and the mud engineer are monitoring the mud weight, and everything is in good condition, so we have primary prevention. But what if we lose this primary prevention? So we will take a kick. Okay, so if we lose this primary prevention, so we will take a kick. So we will shut in the well, okay, using the secondary barrier, which is the BOB. To do what? To kill the well. And what is meant by kill the well? To pump kill fluid. And this kill fluid, what is the meaning of this kill fluid? We are pumping higher fluid with higher mud weight, and this higher mud weight is balancing or overbalancing the formation pressure. How we do this? At the data we got for the shot and drill pipe pressure, and this shot and drill pipe pressure is indicator of the excess pressure from the formation plus the primary control, and we can calculate the kill fluid, pump it, secure the well, and make sure that we restore the primary prevention. Okay, so the cycle of closing, securing the well is to make us back to the primary prevention. Kill the well, calculating what is the required hydrostatic pressure to kill the well, and this killing the well will help us to restore the primary prevention. Then we assess for sure the well, and make sure that the well is secure and we can continue our operation normally. So this is the cycle. Don't forget it, and don't forget also that we are counting on barrier envelope, not barrier element. Okay, so in this case, if we are counting on barrier element, which is the drilling fluid, and we lost this barrier element, and for example, if we don't have pressure tested BOB or leaking BOB or any problem with the BOB, so we cannot close the BOB, so we cannot control this kick, so we might have a blowout. Okay, so this is very important. This is very important. In case we have a liner, we run a liner and do seaming job, and we didn't do negative tests for this liner or CBL, seaming bond log for this seaming, and this liner gap is leaking, and we go to the next section, reduce the mud weight or bump lower weight prime, so we will lose the well control, and we might have uncontrolled flow of the fluid, and we might have blowout. Okay. Okay. So how can you prevent the kick? Okay. You should know what is the causes, what are the causes of the kick, and this is the next presentation for us, inshallah. What are the causes for the kick, and use the correct rig practices. So, for example, what are the correct rig practices? The driller should, for example, activate the alarm for the BVT bits. Okay, the derrick man should inform the driller with any transfer to the bits, to the active bits. If we are tripping in or tripping out, we should follow the trip sheet and pay attention to any deviation from this calculation. So this is just an examples of the best practice. Okay. So again, this is the mud hydrostatic if it is fall below the formation pressure. So we will have a kick. So we have here two scenarios. We have the formation pressure, which we should control. So we have two scenarios here, that the hydrostatic pressure or the mud weight will go down, okay, and the formation pressure is the same. So what are the causes of the falling down or reducing the mud hydrostatic? Anything that will reduce the mud weight, and we will talk in details about this, inshallah. For example, if you have high background gases and you are not intervening with this, you are not running the degasser, you are not monitoring the mud weight, and you have a gas cut in your mud. For example, if you have
a very fine screens, and these screens are discarding the wetting material, the barite. If you are running the centrifuge for a long time, and this centrifuge is causing mud weight to go down and your wetting material to go away, so you will have a lost. So you will have lost mud hydrostatic. Okay. The other case is your mud is still the same. No change happened to your mud, but the formation pressure rises, and this happens when you go to abnormal formation pressure or abnormal zones. And this abnormal zone, we have, I think you know this information. We have this pore pressure graph, and this is the pressure, and this is the depth, and there is a normal pore pressure which is 0.433 up to 0.465 psi per foot. This is the normal pressure, normal pore pressure gradient. Okay. So, for example, if you are at 10,000 feet, you are expecting your pressure 4,650 psi. This is the normal pressure. So you are calculating your hydrostatic to overcome this formation pressure, for example, with 200 psi, which is the trap margin. So if you enter a formation and this formation is high pressure zone, and there is a lot of reasons of high pressure zones, inshallah we will cover it in the upcoming course. So if you enter a formation with abnormal pressure and you didn't count for this, so the formation pressure will rise and your hydrostatic pressure will fall, and you will lose the primary control. Okay, so you have two scenarios here. The hydrostatic pressure to fall below the formation pressure due to any change in the mud weight, or the formation pressure itself, it rises because you enter abnormal pressure zone. Okay. Okay. So let's start with our long presentation for today, which is the causes of kick. Even if we finish the webinar with this presentation, so it will be very good for a short webinar. And in case you want to leave early, so it's okay, we can stop at any point you like, but I will try to finish this presentation inshallah. So Mr. Hassan, please try to admit anyone to want to enter, because this is distracting me. Okay. Okay. So what are the causes of the kicks? I told you before, the kicks can happen when you lose your overbalance and become underbalance. Okay. I saw one of the questions is talking about the underbalance drilling. For sure, we don't have time to cover this, but this is a technique for drilling in the high B, high T wells, and in case we are caring a lot about the formation damage, so we will not cover it for sure, but it is a different technique with different procedure, with different well control practices, so we will not highlight this in today's webinar. So the underbalance is caused by, I told you before, the mud hydrostatic reduction or the increase in the formation pressure. Okay, so this is the golden rule, our golden rule in our golden rule for our industry. Which is any pressure we have, it is calculated by the mud weight of the fluid we are using, multiplied by a constant depending on the units we have, multiplied by the TVD. Okay, so any pressure we have is equal to the mud weight multiplied by a constant multiplied by TVD. The most common one is the constant is 0.052, and we have the mud weight with the BPG and the TVD with feet. Okay, and we got the pressure in PSI, pound per square inch. This is the most common one. Okay, so we have here two reasons, okay, or two factors that causing the pressure to drop. Okay, the mud weight, it might drop, or the length of the mud column might drop. So what are the reasons might help or impact the mud weight? Okay, so let's see here. There is no way to remove this screen from any person who want to enter. It distract me a lot.
I just admitted them in general.
Yeah, there is no way to remove it from my screen at all time.
It is now removed. I will try to pick them in time so that it will not distract you again.
Okay, thank you. Okay, so now the last slide we are talking here. We have the pressure, mud weight multiplied by a constant multiplied by the TVD. So we have two reasons. We have two reasons cause this mud weight. We have two reasons cause this pressure to go down. The first one is the mud weight reduction or the TVD reduction. So let's talk about one by one. So the mud hydrostatic reduction running into bubbles. So for example, if you seeing here, this bit is running into bubbles, and this will cause the hydrostatic pressure to reduce. Why? Because the mud weight will reduce at this area, and we will have two fluids in this well. Okay, we have this this part, okay, which is contaminated fluid with bubbles, and we have the remaining part of the well. And this is one of the questions you will get in case you will go to any IWCF or well sharp exam. Okay, so for example, quick one, whole TVD, the whole capacity, the drill collar and whole capacity, the mud weight, the formation gradient. This is an example of a real question from the IWCF or a well sharp exam. Okay, the influx size, the gas gradient. So what is the effect on the bottom hole pressure when run back to the bottom? Okay, so you have bubbles here, you pull out of the hole, you have trip gases or trip bubbles, and you run into this bubbles, and this will reduce the pressure. You have when you go to the exam, you have equation sheet, you have equation for this type of questions, and you will calculate the effect on bottom hole pressure. For sure, the bottom hole pressure will reduce. Why? Because here you, for example, you have here 10 or 11 ppg as the example, 11 ppg, okay? And you have the gas gradient in this area, the bubble is 0.1 psi per foot. So it will be very easy to calculate how far the gas will go up, okay, and reduce your hydrostatic column or reduce your TVD. You remember this equation? It will reduce your TVD, and it will also reduce. It will reduce the formation pressure, the hydrostatic pressure. Okay, so through some equation, inshallah, at the course, we will highlight this by using the equation sheet and solve many questions about this, inshallah. Okay, you can see here, guys, I'm trying to make quick just because we have a limited time, but this is just introduction of what we are going to discuss in detail in the upcoming course, inshallah. Okay. Okay, so circulating whole clean, when we have a cutting in the hole, this cutting is acting as these solids help to increase the bottom hole pressure. Okay, so when we circulating this cutting out of the hole, and this is for sure, it's very important. So we remove all of this cutting, and in case we have a narrow window, remember this point, because for sure we should clean the hole, but in some cases we have narrow window operation. That's why the MBD, which is managed pressure drilling, is one of the techniques used in these cases. This case, when you have a narrow pressure window, you remember the mud window I told you before, we have the fracture pressure, fracture, okay. We have here the mud weight or hydrostatic pressure. It should be higher than the formation pressure, and it should be lower than the fracture pressure. Okay. In some cases with narrow window applications, you have, for example, 100 psi difference between the fracture pressure and the formation pressure. You are drilling, you got losses. You are you stop the pump, you got flow. Okay, so this is a narrow window application. So also the cleaning, circulating hole clean and removing the cutting, it might reduce the hydrostatic pressure little bit, and in case you have narrow window application, so you will lose part of your hydrostatic. Okay, for sure gas in the well bore, and this gas will reduce the mud weight, and this is called the gas cut mud weight. Okay, the gas cut mud. And we have also the effect of gas expansion. You know that the gas is expanded when it go up, and this expansion will cause the hydrostatic to go down. Okay, for example, if again we have here a gas bubble, okay, and we when we are not monitoring our system, and we let this gas to go up, and the pressure will go down. So when it go up, the pressure on the gas will reduce. Okay, so this gas will be allowed to expand, gas expansion. And this gas expansion, you can see here on the trip tank, there is a fluid to be removed. And what is the result of this? A part of the fluid in the hole will be lost, so your pressure will be lost. Okay, and you can see here the volume of gas at 6,000 feet is 1.16 cubic feet, and at the surface it is 272. So try to imagine how the increase in the volume of the gas, which is translated to loss of TVD and the loss of the hydrostatic pressure. Also, one of the reasons of multi-hydrostatic reduction is the swabbing. When you do tripping out, so it should be in a controlled speed, and this controlled speed should be controlled to avoid any swabbing effect. The swabbing effect is to make like suction of the fluid from the formation by making like vacuum here, and this vacuum will induce the suction of fluid from the formation. Okay. What are the main causes of swabbing? Pulling the pipe too fast, very high mud viscosity, the small clearance between the drill collar and the whole wall, and if you have a pulled up bit, when you have bit pulling from any clay or any chemical or any formation, so also it might help to increase the swabbing tendency or the swabbing effect. Okay. Also, one of the causes of reducing the hydrostatic pressure is pumping light mud, and for sure, pumping light mud here it will be by accident. It is unintentional pumping. It's not intentional, because sometimes we pump light mud. In some cases, for example, we are doing negative test. In some cases, we are doing something called tandem bells, and this is used for cleaning in the highly deviated and horizontal wells. But for sure here, when we are doing these tandem bells, we are doing it in calculation. So we are pumping low weight mud, followed by high weighted bill, and this will equalize themselves, okay, to provide the required bottom hole temperature. But when we are talking here about the pumping light mud, it will be unintentionally, so it will go down, and once it go out from the pit, it will reduce the bottom hole pressure, causing a reduction in the mud hydrostatic. Okay. Also, I told you loss of the barite, so we might reduce the mud weight. So loss of the barite, it comes from centrifuge. You are running centrifuge for a long time, and you are not following the mud weight properly. You have shakers discarding the barite. You have the filter. Also, it might cause barite to go down and poor mud settling. Okay, so you might have, for example, a low viscosity mud with high barite content, and this causing the barite to settle. Okay. Okay. So one of the most common reasons of losing well control or losing the primary prevention is the losses. And the losses, you can imagine that when you have a losses, so you will lose the hydrostatic column of your well, and for sure this will induce the reduction of the mud hydrostatic, and the formation pressure will exceed it and go inside the well. Okay. Okay. Also, pull out without filling the hole. I told you one of the good practices, when you remember at the start of this presentation, the good practices at the rig. When you are pulling out, you should follow the trip sheet. Okay, you have trip sheet. You are filling it based on what you have inside the well. The trip sheet, inshallah, or the kill sheet will be discussed in details in the upcoming course. So you have a kill sheet or trip sheet. You should follow it, and if you are not following it, if you are not filling the hole while tripping, so you will end up with lost hydrostatic pressure. So you can see here the metal displacement is removed without filling, so you will lose this part of the fluid. Okay. Pull out of the whole dry. So you can see here also pulling out dry or wet. And this also part of the questions come in the IWCF and well sharp exam. It gives you some equation and some examples told you that we are pulling out of the whole dry. So what will be the lost hydrostatic or lost level of the mud? So for sure, the difference between dry and wet is the metal displacement and the inside displacement or the inside capacity. So this is inshallah will be highlighted in details while we are doing some calculation using the equation sheet, and we will highlight some of these examples which for sure you will see it in any exam of IWCF and well sharp. You can see here, let's go back, this dry. So if you pull out dry, so the metal displacement will be only the factors that affecting the filling of the hole. If you go wet, so if you go wet, so the reduction will be higher. So like this, so it should be calculated very accurately to fill the hole based on this calculation. Okay, that's why we have many equations differentiating between the pulling out wet and pulling out dry. Okay, so this is the part of the equation sheet. Inshallah, you will get in case you are testing IWCF or well sharp, and inshallah we will go one by one in this equation sheet in the upcoming course. So for example, here is the drill pipe, the dry pipe, the mud gradient multiplied by metal displacement over the casing capacity minus metal displacement, and here's the wet pipe, and here's the casing capacity. Okay, so this is part of the equation sheet, and this is also part of the examples that we will solve together. And also here there is a difference between the collars and drill pipe. You know, drill pipe is small relative to the drill collar. That's why we have a different equation for the drill collars, pulling it wet and pulling it dry. So we should also count for this drill collars, okay, and fill the hole as per this calculation. Otherwise, we will lose the hydrostatic. Okay, and this is also part of the examples. In case we have a float collar, and this float collar is we use it, for example, in while running a casing, and to prevent any cement from returning from the annulus. So it is one-way valve. We are pumping cement here, and it opens the valve and go in this area. And in case of the failure of the float valve, so the calculation will be different. And you can see here the flow will be lost, and you will lose some of the hydrostatic. Okay. And also there is a question that 100% you will find it in any IWCF or well sharp test. Okay, inshallah. I'm fast because we are already we finished already our 1 hour, but I will try to finish this. But as I told you, this is just teasing for what we are going to introduce or provide you in the upcoming course. Okay. So what are the key prevention practices for this? So don't run in hole too fast, because this will increase the possibility of surging. The surging is the opposite of the swap. So surging, you can make surge, and this will increase the possibility of losses. Monitor the trip tank. This is very important. If you have very accurate trip sheets, so you should monitor it. Always fill the hole with the correct mud. Here is the correct mud. It means the correct mud weight. So any mud go inside the hole should be monitored by mud engineer and the derrick man to avoid any reduction in the mud weight. Monitor the ACD, and I think most of you or all of you know what does the ACD mean. It is the equivalent circulating density, and it is the density come from the friction of the drilling fluid with the annulus, and this is extra pressure applied to the bottom hole, and this is also should be accurately monitored to avoid any increase in the ACD, and it will reduce increase the possibility of getting gate losses. Okay, keep the viscosity down to acceptable level. Inshallah, when we talk about the mud parameters, every time I told anyone attending with me any drilling fluid course, the drilling fluid parameters is should follow a certain range. The viscosity is very important for hole cleaning, but it should be high enough for hole cleaning, but not increasing the friction, not increasing the ACD, and it should also be in a range that that prevent the swabbing effects while pulling out of the hole. Okay. For sure, keep the casing full all the time while running the casing, and know what mud is in the hole. Okay, that's why it is very important for the derrick man duties to monitor the mud weight and announce it every 30 minutes, and in some time at the critical operation every 15 minutes. Okay, so this is very critical. I told you there is a lot of causes for abnormal pressure, but I will not highlight them now. The under compaction, the faulting, sand lenses, the salt dunes, the artesian effect, the gas cap, the leak around casing. The most common one is the sand lenses and the faulting, but we will not cover them now because we are already ahead of time. We already late for finishing the presentation. Okay. Okay. So I told you this is sand lens, is most common one. What is sand lens? It is sand formation surrounded by shale formation, and this shale formation is causing the fluid not to escape. You know, there is something called the permeability, and the permeability of the shale is very low, and the permeability of sand is high. But due to this low permeability, the fluid is not allowed to go out. So that's why it will be trapped, and you will find high pressure in unexpected depths, and this is the sand lens. Okay, so we will not inshallah we will cover all of this in details in the next course, inshallah. I think we already finished our planned hour. I know we didn't cover a lot, but this is the webinar. It is not a course. It's just a quick introduction of what we are going to cover. So let's talk to you quickly what we will cover in the upcoming course. So we will continue the causes of cake and abnormal pressure situations. We will highlight the warning signs and indicator of a cake, and this is very important. I told you one of the practices is to monitor the cake, and you have warning signs. Warning signs, something warn you like a yellow light, be prepared, something is going to happen. Okay, and in case already you have a kick, so you should know what to do to shut in the well. Okay, there is two common shut-in methods. the soft shut-in, the hard shut-in. What are the difference between these shut-ins? When you shut in the well, you wait for the pressure to stabilize and you should collect some data, okay? Collect some data. So what are the data to collect? Shut-in drill pipe pressure, shut-in casing pressure, the bit gain, and you should have pre-filled kill sheet, okay? So we will stop and describe the kill sheet line by line, and this will be one of your duties while doing the course with me, is to fill the kill sheet yourself, okay? I will help you to understand the kill sheet line by line, and one of your duties or assignment, you will fill the kill sheet yourself, inshallah. Okay, so after you fill the kill sheet and you prepare your kill fluid, so you have different methods of killing the well, the driller method and wet and wet method to remove the influx. So what are the difference between them? What is the preferred method in which situation? You have also the volumetric method or stripping method. What is this? So you should understand what is the volumetric method and when we are going to use it. So in case you are doing killing operation, you are not expecting that everything will go smooth as you plan. So you might have some problems. You might have, for example, a washed choke or plugged choke. You might have a wash in the drill string. You might have any a lost nozzle, for example, in the pit. So what will you do in this situation? Okay. Also, we will go to the second part of any well control test, which is the equipment. We will highlight the POB. We will understand every part of the POB, the choke manifold, the mud gas separator. We will understand our response to any problem in this equipment. Okay, so we have a lot to cover, but for sure this webinar is a short time. We cannot increase more than this in this webinar for your time and my time. And inshallah, in the next course, we will highlight all of what we got here. Okay, and be ready with your calculator, your scratch paper, even your kill sheet. Inshallah, we will provide a kill sheet for you so that you can work on yourself. And inshallah, see you in the next course. I hope inshallah I will see you all of you, and we got benefit that you require. And we have 10 minutes for your questions. So please, Mr. Assam, highlight the question.
Okay, thank you, Engineer Amr, for this interesting presentation and very interesting topic as well. Guys, I have sent the feedback link for this webinar in the chat area. So you have 2 minutes to fill in the feedback form and prepare your questions as well. Please be specific in your question in order to know which part of the presentation you have your question in. So waiting for your questions while you have the time to fill in the feedback form. Also, I would like to add a note that this topic is very interesting topic in the time of increasing activities of the drilling operation worldwide, offshore and onshore. So controlling the wells and for the safety of the people and the equipment is something very crucial and very important. So I really encourage you all to register in this interesting course to know more about the procedures for controlling the drilling operation and the rigs as well.
Okay, Mr. Assam, just a minute. I have some interesting question to reply. So there is a question from Muhammad here. If the influx is is formation water. Should we apply shutting procedure? For sure, yes. I told you, you have downside. Try to imagine if you are drilling a water well, okay, and we got a water influx and we shot in the well and we find high pressure in shot in drill pipe pressure, shot in casing pressure. So you have a water influx or a water kick. So it doesn't matter what is the source of your kick. We are talking here about pressures, not the type of the fluid. Water influx is easier to be handled than the gas influx. What is the problem of the gas influx? The gas is migrating while you are shutting the well in, okay? So the gas is migrating, and due to this migration, the pressure increase on the surface, and we should do something called bleeding and lubrication, okay, to avoid the effect of gas migration until we prepare the kill fluid. But the water influx is the same as oil influx, is the same as gas influx. We should control our well. It is well controlled. It doesn't matter what is the fluid we have. Okay, so this is a good question. So we should control our well, whatever the fluid is. We should control our well. We have another question here. What can we do in case of blowout and the blind rams off? I can't understand what you mean with blind ram off. You mean the blind ram is not working? So in case we have a blowout, so the first thing to do is to escape for sure, and just a minute, okay. In case we have a blowout, the first thing is to escape with following the rescue team instruction. And regarding the blind ram, in case you can from a distance, for example, as you know, the BOP control unit is located beside the tool pusher office, and he tried to close the well. So he will try to close the anaerobe preventer if he cannot control. So he will close using the pipe ram. In case the well is without pipes, I think this is your question. So he used the blind rams or shear rams. Okay, shear rams also it can work on the empty well. Okay, so you try to close the well in case you cannot control it, so you will escape. And the most important thing for sure is the personal safety. And then another team will interfere to, for example, drill a relief well, like what happened in the Deepwater Horizon. There is a lot of consequences for this. What causes the bubbles? Is it gas? Yeah, sure, it is gas. When you have gas, when you have tripping, and you have something we call the trip gas or round the trip or something like this, you have gases from the formation. And when we have gas formation or high pressure formation, most of the time, like for example in Saudi Arabia, there is a formation called Jelh formation, and this Jelh formation is common of high pressure. So when we make trip out and the trip in again, we are expecting we might have some trip gases at the bottom of the hole. So we should circulate bottom up first before continuing drilling to avoid any effect of this gas bubbles. Okay. Should we apply control procedure if the formation water? Yes, we already replied to this. Use the plug to segregate kill fluid. In case we are for example, when we are doing well control, and in case we have well control and we have a fluid inside the well, so we might use like a plug ahead of this kill fluid. I think you know the procedure of pumping cement, right? We pump cement, the bottom plug and the up plug, the top plug, and the cement in the cement. It is something like the cement plugs to isolate the kill fluid from the other fluid to avoid its weight to reduce. Okay. Can we, at the end of the webinar, I don't know about the slides. I will discuss with the guys with the OBA. For underbalanced drilling, what the criteria is applied? I told you the underbalanced drilling is a very big topic. I cannot give you a very short answer here. It will be, it will not cover your question. Okay. What else we have? Okay, I think this is all of the questions. Thank you, all of you, for your questions. I like, just for your information, inshallah, in the next course, I like a lot participation, your question, your voice interaction with me, and your question or participation is enriching the course. Okay, so inshallah we will I hope we will have a good course, inshallah, with all of you. And this is the end of my talk, and thank you, and assalamu alaikum wa rahmatullahi wa barakatuh, everyone.
Thank you, Engineer Amr, for this fruitful session. Please note that the certificates will be sent within 1 week from today. And thank you for attending.
Thank you, and see you, inshallah, all of you. Assalamu alaikum.
Thank you.